A bridge is built. It opens on schedule. The cost comes in below the original estimate. Everyone involved considers this a success worth repeating. The rule that made this possible was simple. Every public contract must go to the lowest bidder. That rule was designed to protect public money from waste and favoritism. Before this rule existed, contracts were awarded informally. Political connections and personal relationships determined who built public infrastructure. Costs were largely uncontrolled and unverifiable. The lowest bid rule replaced judgment with a number. It removed discretion from the process entirely. The lowest number became the only criteria that legally mattered. Contractors understood the rule immediately. To win work, a bid had to be the lowest number submitted. Everything else about how the work would be done became secondary to that constraint. To submit the lowest bid, contractors had to cut something. Material thickness was one place where cuts were invisible at the time of submission. Thinner material cost less and passed initial inspection equally well. Inspectors checked whether materials met the minimum specification. They did not check whether materials exceeded it. Meeting the floor was sufficient. Exceeding it produced no reward. Specifications themselves were written to define the minimum acceptable outcome. They were not written to define the optimal outcome. The gap between minimum and optimal was invisible in the bidding process. Each winning contractor passed all required checks. Each project was formally completed on time and within budget. The system recorded every outcome as a success. No record captured what had been quietly removed. Infrastructure built to minimum specification looks identical to infrastructure built beyond it. Externally, the surfaces are the same. The difference exists only inside the material, where no observer stands. Time passes. Infrastructure carries load every day. Materials near their minimum threshold degrade faster than materials built with margin. The margin that was removed was also the buffer against time. Maintenance budgets were set against the assumption of standard material performance. When materials degraded ahead of schedule, maintenance costs arrived before the budget cycle anticipated them. The timing gap produced shortfalls. Infrastructure agencies did not track which projects were built by which contractors. The procurement record and the maintenance record were stored in separate systems. No direct line connected a low bid to a future repair cost. Without that connection, agencies could not identify which structures needed earlier inspection. Resources were spread evenly across all infrastructure. Higher-risk structures received the same attention as lower-risk ones. Meanwhile, the lowest bid rule continued operating across new projects. Each new cycle produced another round of minimum specification selections. The stock of infrastructure built to minimum threshold grew larger with every passing year. No single project revealed the pattern. Each project in isolation looked acceptable. The pattern only existed across the full collection of projects, which no single person or office was positioned to observe. Contractors who submitted higher bids with better materials lost contracts consistently. Over time, they exited the public sector entirely. The pool of bidders gradually self-selected toward firms optimized for minimum cost production. This was not intentional selection. No agency chose to exclude high-quality contractors. The rule created conditions where low-cost producers won repeatedly, and the rest adapted their business models or departed. The rule had also become embedded in legislation. Changing it required political processes that moved far slower than the infrastructure degradation it had set in motion. The rule and its consequences operated on different timelines. Engineers eventually began flagging structures that were aging faster than models predicted. They submitted recommendations for early inspection cycles. The recommendations moved through approval layers before any action reached the field. Approval layers existed to coordinate resources across many competing needs. They were not designed to accelerate responses to degradation signals. Legitimate priorities competed with each other inside the same constrained budget pool. Future videos on this channel examine how similar decision rules shaped outcomes across roads, pipelines, and public housing. Subscribing ensures those analyses appear in your feed when they are released. Some structures reached a condition threshold where repair was no longer technically viable. At that point, full replacement became the only engineering option. Replacement costs were many times the original construction budget. Replacement required full closure. Closure disrupted traffic, commerce, and emergency access. Disruption costs were borne by the public and by businesses. They did not appear in the infrastructure agency budget. Replacement procurement also operated under the same lowest bid rule. New structures were selected by the same mechanism that selected the original ones. The replacement cycle began with the same structural conditions as the first. Some agencies attempted to introduce quality scoring alongside price. These reforms required defining quality in measurable terms. Measurable quality terms were contested by contractors whose business models depended on the original rule. Quality is difficult to define before a structure is built. Observable quality only manifests under load and over time. Procurement must commit to a contractor before either condition can be observed. Some jurisdictions introduced bonding requirements. Contractors had to post a financial guarantee against future defects. This shifted some risk back to the contractor, but bond periods were typically shorter than infrastructure life cycles. A 5-year defect bond on a 50-year structure covers 10% of its operating life. Defects that manifest at year 12 fall entirely outside the bond coverage. The contractor bears no cost for those outcomes. Agencies that recognized the problem began experimenting with life cycle cost analysis. Instead of comparing only construction bids, they modeled projected maintenance costs over decades. This changed which bids appeared cheapest in total. Life cycle costing required accurate maintenance forecasts. Accurate forecasts required historical data on how materials degraded. That data had not been systematically collected because no one had anticipated needing it at procurement time. Without historical data, life cycle forecasts relied on engineering assumptions. Assumptions introduced uncertainty that some procurement officials were unwilling to accept as a basis for contract decisions. The simpler rule persisted. As infrastructure aged across the network simultaneously, inspection demands peaked at the same time. The structures built in the same era needed assessment during the same window. Inspection capacity could not expand at that rate. Structures that failed unexpectedly produced emergency repair costs at market rates rather than planned rates. Emergency procurement bypassed competitive bidding by necessity. The cost premium for emergency work was substantial. Emergency costs were absorbed by contingency reserves. When reserves were depleted, planned projects were deferred. Deferral of planned projects created future backlogs. The backlog compounded the next budget cycle's constraints. Political attention arrived after visible failures. Investigations examined contractor practices and material choices. They rarely examined whether the procurement rule itself had shaped what contractors were able to offer in the first place. The procurement rule had originally solved a real problem. Removing discretion had reduced corruption and improved budget predictability. These benefits were real. They simply produced a second-order cost that was not anticipated at adoption. Rules that solve visible problems are difficult to reform because the visible problem is remembered while the second-order cost accumulates silently. Reform proposals appear to reintroduce the original problem. Advocates for reform carry the burden of proof. Some jurisdictions introduced weighted scoring models combining price and technical merit. True. Trastaiwad Wadel Imzadi. Implementation required new evaluation capacity and staff training. Transition periods left gaps where the old rules still applied to some contracts. Where weighted scoring was adopted, bid pools changed. Higher quality contractors re-entered markets they had previously abandoned. The cost per project increased modestly. Long-term replacement cycles lengthened noticeably in tract jurisdictions. Jurisdictions that did not adopt reforms continued operating under the original rule. Their infrastructure portfolios continued accumulating structures built to minimum specification. The cost difference between the two approaches widened with each passing decade. The total cost differential is difficult to calculate precisely. Maintenance records, replacement costs, and disruption losses are recorded in separate systems by separate agencies. Full accounting requires assembly that rarely occurs in standard budget processes. Conservative estimates place the accumulated replacement premium at several multiples of the original construction savings. The savings were realized immediately and credited visibly. The replacement costs arrived decades later and were never attributed to the original rule. The rule is still active in various forms across many procurement systems today. Its original rationale remains intact. The infrastructure it produced continues to age. Maintenance obligations attached to it continue to accumulate inside public budgets. The system carries its past forward. Each structure holds the decisions made at the moment of its procurement. Those decisions do not expire. They become visible only when load, time, and minimum margin finally meet.